All right, let's start with part A. We have sine squared x cosine x dx. Um, we can try using trig identities maybe, or maybe going in the direction of having a u substitution because we have sine raised to the power of 2x, right, and cosine x dx, and calling u to be sine x, I think would make it work, right, because du is going to be cosine x dx, and then we can convert that integral to u squared dx eventually. But be careful, this is a definite integral. So we're going to do the indefinite integral first, and once we're done with that, we're going to use the fundamental theorem of calculus to write down the value of the definite integral. Okay, so why don't we separate this first? That I'm going to work on. The indefinite integral first. So that is sine squared x cosine x dx. Okay. So I'm going to use a u substitution here. Okay, u I'm going to call, as I said, u to be sine x. By the way, you can pause the video and maybe think about alternate ways to handle this problem, because integration is not just like just one way to go. It's like you may have multiple ways to be used to get to the same result. So so these are my initial guesses to start with, and again, if you have your own way to go, yeah, go with that. And as long as you get this integrated, we're good to go, right? So du equals cosine x dx, which is the derivative of sine, right? So boom, so we can go back here and convert that integral to u squared du. That allows us to use the power rule for integration. It's good. So this is u cubed over 3 plus c. We don't need to put a c because we are we're trying to use the result of this indefinite integral towards calculating or evaluating the definite integral. So we don't really care for that c, but anyway, let's do it. Sine x cubed over 3 plus c, or sine cubed x over 3 plus c. These are alternate ways of writing cubic power for trig functions, right? So now, since we're done with integration, I can go back and I can go back and write that. This is sine cubed x over 3 from 0 to pi. So I'm going to do two evaluations. One is sine cubed pi over 3 minus the lower limit plugged in, sine cubed 0 over 0. Okay. This moment, if you have a calculator, go ahead and punch in sine pi and sine 0 and then raise them to the power of 3. Okay, let's just do it. All right, sine pi, you should get that to be exactly equal to 0. And then obviously put your calculator in the radian mode before you use your calculator. So sine pi is 0, sine 0 is 0, so 0 minus 0 is going to be 0. So the value of this integral is going to be 0. Okay. As I said, to be able to handle definite integrals, you first have to handle the indefinite integral version of that. So that's free of upper lower limits. And once you're done with that, you can go back and then use the fundamental theorem of calculus to do that. You can also convert, by the way, like when you have a u substitution, you can convert the limits and write them in terms of u's. But I prefer not to do that because I think it's easier for me to just get done with the indefinite integral first and then go back and use the original limits provided in the problem statement. Okay. Let's take care of part B in this video as well. Let's try to squeeze that in. All right, let's consider part B. So we have well, let's rewrite this without the limits. Okay, so 1 minus ln x divided by x dx. And you can start thinking about what technique we should apply for this. But I think we know that ln x has the derivative 1 over x. So I have 1 over x in the bottom. I mean, 1 over x is in the bottom, so that's a 1 over x type term. So why don't we call u to be 1 minus ln x, so that in one shot we can take the derivative of that and we get minus dx over x. So that I can replace dx over x by negative du. It's good. So I have minus u du. Okay. So u substitution in this problem in one shot, converting that integral to something that we can easily integrate. So that's minus u squared over 2 plus c. And u is 1 minus ln x. Quantity squared divided by 2 plus c. Okay, that's good. And I don't need to worry about c, the integrating constant, for the evaluation of the definite integral. So here we go. So this is minus 1 minus ln x quantity squared over 2 from 1 to e. We're using the fundamental theorem of calculus, right? So we're going to plug in e first. And then I'm going to plug in 1. Okay. And go ahead and use your calculator. But visually verify that ln e is 1. Okay, that's one thing that you should be able to see here. Okay, and for that reason, if ln e equals 1, 1 minus 1 is going to be 0. So this is going to be 0, right? And ln 1 is 0. Okay, so it turns out that the result here is going to be minus 1/2, which is in fact 1/2. All right, I can go back and then write that this is equal to 1/2. All right. So this takes care of part B. We have 2 more to go, but I'm going to finish this video right here. So please move on to the next video. Bye.